Good morning. Happy Monday. All right. Going with day 12. We're almost at 2 weeks here. I cannot believe I've been able to keep up with making these daily videos. The streams are easy. The videos I've been putting together, those have become, they're taking longer to make. The first couple were easy, short, put them together fast. Now they're taking, yesterday's I think took me a total of 3 hours to put together, 3 or 4 hours. I'm not sure. It's too long, too much time. I didn't think yesterday's would take so long. Smab got the notification. Smab. So I think what it is on the last two, I didn't change the name of the stream. I didn't change the name of the stream before I started streaming. So I think Twitch felt like you had already seen. I don't know the details, but I tried changing the name before I started the stream this time. Well, actually, I started the stream and then realized I hadn't changed the name, so I stopped it, changed the name, and then started it. So did you get 2 notifications or just 1? I hated this. When you say hated this, is it hated that you're trying to keep up with it daily? Fascinating. All right, I don't know what the deal is then. I don't know. That's funny. I purposely tried doing the second one. All right, so now people. Oh, today's puzzle. Oh no. I've only seen the name Hill Climbing Algorithm, so I was slightly worried it's gonna have some kind of machine learning thing in there, doing like some kind of hill climbing. I'm hoping that's not the case. So like doing an actual hill climbing algorithm, because then I'm not gonna be able to make a guide to it. For my students won't be able to. Maybe they won't understand why. They don't understand the reasoning behind it all. Anyway, okay, well, how's my volume? I messed with my mic a bunch yesterday. Is the voice coming through fine compared to like the music and stuff? Can you hear me okay? I'm assuming so. Great. Oh, yeah, I've been with these videos. I went back and rewatched some of them, and there was noise. I could hear. It's weird listening to yourself and like being super critical. It's probably fine, but the videos, I can hear like this mild. I could hear this mild noise in it that was bothering me. So I fiddled around with a bunch of settings trying to get rid of it yesterday. All right, let's take a look at this hill climb, day 12, hill climbing algorithm. You try contacting the elves using your handheld device, but the river you're following must be too low to get a decent signal. You ask the device for a height map of the surrounding area. The height map shows the local area from above ground into a grid. The elevation of each square of the grid is given by a single lowercase letter, where A is the lowest, B is the next lowest, and so on up to the highest elevation, Z. Also included on the height map are marks for your current position, S, and the location that should get the best signal, E. Oh, I didn't even know you could do triple quotes in C#. For multi-line strings, I didn't know you could do that. I thought I had to start with the @ to do multi-line strings. I didn't know that was an option. Here, I'm gonna test that real quick. Oh, I don't know if I'm even on C#11. I'm using .NET 6. So the class I'm teaching this term uses .NET 6. So .NET 7 wasn't out when I started, so all of my students have .NET 6. That's why. That's why. And I'm not even sure. I'm not even aware of all the C# 11 features. All right, so we have a height map, A to Z marking the heights. We also need to keep track of the height of S and E here. So S has the same elevation as A, E has the same elevation as Z. Oh, give me just a second. I'll be right back. I gotta shut a door. My dog, it's freezing outside and my back door is open. I gotta go close it real quick. All right, we are back here. Sorry about that. I have a yeah, it's just I could feel the cold air creeping in. Usually I like to leave. We have a screen door. We have a sliding door, and then the screen door has a doggy door. But it's just too cold to have it open right now at 5 in the morning. Usually the desert's not that cold. Let's check it out. Let's look at this. Ooh, I like that. It ignores it's gonna ignore the white space at the beginning. I think I saw a post like this on the C# subreddit. The indentation is taken from the last. That's a nice little feature. Makes it easy to paste stuff in for sure. This would be nice. I like that. Well, maybe someday I'll do C# 7. One of the things that I hate is my Unity. So I'm going to be teaching Unity. I've taught Unity in the past. Uses some. It claims to use C#, but it's not actually C#. It's like C# 8 compliant, but doesn't actually have all the features of C# 8. I forget exact details of it. And it also is on .NET 2. You can technically, there's like a button you can click to say use .NET 4. So it's a little sad. I'm going, these guys, they gotta update this. They gotta get this to the newest version. Hoping they'll update to 6 because 6 is long-term support. I think 7 is not long-term support. Correct me if I'm wrong. Doesn't mean you can't use it, just means that there will be a new version coming out. All right, you would like to reach E, but save engine race, you should do it in as few steps as possible. During each step, you can move exactly 1 square up, down, left, or right. To avoid needing to get out of your climbing gear, the elevation of the destination square can be at most 1 higher than the elevation of the current square. That is, if your current elevation is M, you could step to elevation N, but not to elevation O. This means that the elevation of the destination square can be much lower than the elevation of the current square. All right, so you can only go up 1, but you can go down. You can jump as far down as you want. Oh, no worries. I'm always excited about new features. It just means that I will I'll start using them the next time I start a new C# class. So in the next term, I probably go and update my book a little bit, my workbook that I'm working on. Maybe not. Maybe I should finish writing it first for .NET 6. All right, so we have a map here. Alphabets, all lowercase, I'm assuming, based on this input, A to Z lowercase. And then we have a capital S and a capital E for start and end. E has a height of Z. And then this is sort of the way the spaces that are possible to move into it. Okay. So this, unless I'm missing something, this is just a maze puzzle essentially. You could use breadth, find the shortest path, so breadth first search. See if I can dust off the old breadth first search here. find the shortest path and then do a backtrack to get back to our beginning. I'm a little worried that the next puzzle is gonna be weighted or something, and then I'll have to implement a weighted algorithm like Kruskal's Prim or probably Dijkstra's is probably what I'd use. Okay, so we are going to implement a breadth first search here. All right, so let's tree walking, etc. It shouldn't be too bad. It just have a loop that says like, well, we'll set it up. We'll see if we can get it working. Keith, you've been visualizing all of these, or did just today's? All right, so we need to read our input in to a height map here. Make sure. All right, let's get an example. File, new file, example. And we'll go and get my input as well. Ooh, that's a big input. That's cool though. I like how you can kind of see. It looks like a topography map already. You can kind of see the mountain over here. Let's just copy that. Input. I really liked the knot puzzle. I think could be a really cool visualization, and I was thinking the stack puzzle. I saw some really cool stack puzzle ones. I didn't see any that were like crazy cool. I thought the stack one could be done really, really cool, but using like real physics. Cool. All right. The knot one, I feel like you could do some really cool stuff with. I saw someone made a snake game using the knot physics. So instead of, falling perfectly behind your tail sort of follows you like the knot physics, and I thought that was pretty cool. Okay, so we got to read this in string rows is equal to file dot read all lines. Example. And I want to get a I'm gonna get a 2D grid, a two-dimensional grid of, well, I don't know the size ahead of time, which is annoying. I'm assuming it's not a square. This does not look like a square, but I've been fooled before. Oh, that's okay. I have this split up into lines, so I'll know ahead. Height map. And so it's gonna take in a string of array rows, and it's gonna generate an int height map, new int array. We have rows dot length, so we're gonna have that many rows, row and column, and then we are going to have that many columns, rows dot length. All right, and then we're just gonna iterate through for int row equals 0, row less than rows dot length, row plus plus, for int column equals 0, column less than rows of 0 dot length, column plus plus. We'll get a height in here. Let's check it out. Ooh, I like it. Cool, very cool. Let's see here. We were pulling out this height map. And then this should height map of row column is equal to a or rows at row column minus a, but we have a special case for capital S and capital Z. So I could just replace capital S. All right. Say if. All right, we'll do char ch is equal to rows at row column. If ch is equal to s. Oh, this is so annoying. All right, we'll do this. Int char height char ch. This will be slightly better. Return ch switch s goes to 0 and e goes to, here, we'll do this. Here, we're gonna do this. Int the e. Otherwise, we'll just. This is dumb. My brain's not ready for this yet. Ooh, a 3D rendering would be cool. 3D rendering would be great. All right, so then we will just get the char height of rows at row column. All right, so this will give us our height map. Then we need to well, this is annoying because now I need a data type that sort of has all right, we'll create a new data type called height map and public record. It needs an int array map a row column start and an int row, an int column end, like that. Public record height map. But we also need to do like this backtracking thing, so I'm actually going to create another record called position, and position is going to have a row, an int column, so that my intuition, I'm thinking ahead about how to do the backtrack, and it's going to have a previous position from essentially denoting where we came from. All right. And we'll have a start position and an end position. Let's think here. We're gonna try this. And so when we're building this up, we're actually going to get a height map. Actually, let's just add this as a method in height map. I have never been much of a, I'm with you. Public static Mab, I'm with you on the how to render things. I'm not a. Everyone always wants you to be a front-end developers, people who do UI stuff, UI UX stuff. Oh, bless the good ones, because they are few and far between. We're gonna have a height map here, and it's gonna take in our height map. Then we have to do a start and an end. I guess I don't really have to detect it from the beginning. We'll go position start equals null. Geez, position null. And then when we find the start, we'll just assume we're gonna get them here, lowercase s. Start equals start equals ch row column ch, and we will say that equals ch is s, returns if it's s, new position row column null, otherwise start. And oh man, the client, you can make good money doing it though. So I've done a lot of freelancing in the past. Working for just building web apps or mobile apps, but God, is it a pain in the butt to work with some of those people. Can't. Okay, all right. I think everyone here can probably agree that having good requirements is so nice, but front end people, they just want it to pop. It's not popping. I can do the functionality people want, of course, but man, do I not. I'm not the right person I don't have an eye for what is pristine. And it, gotta hire someone else for that. I'm not that guy. Okay. Let's see if we can parse in. So we'll get a height map. Map equals height map dot parse rows. And can we make an easy print method for this? Public void display map. For each for int, we're gonna do this, but this is gonna be map dot get length of rows, map dot get length of columns, console dot write map at row column, console dot write line, console dot write line, just to give ourselves confidence that this was parsed in map dot display map. Run project Evolution. Oh, hang on. Right line. Let's do it. Let's give each one of these 3. Let's subtract minus A minus D minus A. There we go. That looks much better. At a glance. Ooh, what's this? Something's not right there. Oh, minus A. Okay. Glad I looked at that. I almost botched that. All right, ZZ. Okay. This looks pretty good for my height map. At my start position, at my end position. So now I need to write a function that we need to keep track of the places we've visited as well as where we can move to. So maybe I write a solver. Or do I put it right in here? Considering what to do here as far as structure goes. So I have my height map. I need to have something like gets my valid neighbors, but I also, when I'm exploring my valid neighbors, if I've already visited a spot, I don't want to go there again. So I think I'm actually going to have a different class. And let's move our position in here, I think. And solver, public class, public record solver. So that's going to take in a height map, and we need to explore. So we're going to have a queue. Maybe I just do it directly in my program here. All right, let's do it directly in my program. We want to think this through. We have to have solve. But I want to do it here. I'm going to go ahead and put it in solver so it's testable. Public list of positions. I can also just do position. So it's gonna give us back the solved position. Position question mark. Solve. And so ideally we're gonna return the last position in our map. We need a queue of positions to visit. We need a current position. Well, we're gonna pop them off. All right, so to visit actually starts with map. Oops. Map.start. No parentheses there. Map dot height. Hang on. What did I call it? Start. Can I not do this? Position does not contain a definition for add. Oh. Alright, well, to visit dot in queue start. Math.start. All right, so that's where we're gonna start. We need a visited. So we'll have a hash set of position visited. Equals a new one of these, but lowercase for our correct styling. And then we need a way to get the neighboring positions. So public hash set position get neighbors, and we're going to take in our set of positions visited, and we are only going to add in places we can visit. Okay. For now, we're going to return null. We get null, it means that there's no solution. We are going to build up a hash set. The hash set here is probably completely unnecessary. Neighbors. This will get our neighbors. Yeah, we'll get our neighbors. Those are going to get added to the queue. So our neighbors are going to be our orthogonal directions. So position would be nice to have. All right, so my position, we are going to do some helpers here. Public left, public position, and we'll call this north. This is going to be this with row equals row -1. Is that right? All right. And from is equal this. Okay. North, east. Let's do south next. South. This will be our rows increase downward. Should probably call these X and Y. It's going to confuse my students and so when I go to rewrite this solution, I will probably use X and Y. East columns increasing. West column decreases. All right, so we're gonna get our neighbors, and then we add them in if they're in the bounds. Neighbors equals, we'll do this, list of positions, and this is going to be, oh, we also have to take in our current position. Positions from neighbors from this one, get our visited, and it's going to be from dot north, from dot south, from dot east, from dot west. Oh no, this isn't going to work because my hash set, the equality on these isn't based on the row column, it's based on the entire record here. So that from thing is gonna mess us up. Okay, I can't unless I override the equals and hash code. Public, what would be? I wish I was in Visual Studio and I could just override them. All right. The backtracking here is gonna be annoying if I change that. Let's change visited to row int column. Yeah, so the main reason I don't use Visual Studio is because I teach students on different operating systems. So if I was teaching just on Windows, I would use Visual Studio. But I teach students who, most of my students are actually on Mac. I have a handful of students on Windows, and I have like 3 students who use Linux. Visual Studio, I don't even think there's one for Linux. The version for Mac is not like Visual Studio for Windows at all. It's close, but there's issues with it. And then the alternative that I've heard good things about is Writer, but I haven't wanted to. It's not free, so you have to pay for it, and so I don't want my students to have to pay for something. So I use Visual Studio Code specifically so that I know the quirks for when my students get it. The other thing that's nice is I do like my students to learn a little bit about the command line. So it forces, there's not like buttons to like create a new project. It forces them to use the command line, which I love. Honestly, I would be using Emacs if it wasn't for the fact that my students hate Emacs and it would just not work out well. Also, to be fair, yeah, Keith, I know, but then when they get out, then they have to buy it. That's how they get you. Honestly, I wish I could just use Emacs. I've thought about creating a class called, Intro to Programming in Emacs, and I teach kids Lisp, Emacs Lisp. Yeah, when I was in industry, I used Emacs and people thought I was crazy, but I swear I was more productive than anyone else using Emacs because I didn't have to deal with the IDE issues that they'd run into. But you have to know more about the tools you're using if you're using an IDE. People think I'm crazy that I used Emacs to program in Java for years. Okay. This becomes int. These are ints. Public as pair. I'm using Windows here, but Windows is a very recent development for me. It's because I've been doing Unity development, so I wanted a computer that could develop in that environment. I used almost exclusively Fedora and Ubuntu for many years, and before that I was a Mandrake Linux guy. All right, so this, I've written myself into this weird hole here. Neighbors dot select and as pair, or we only want to keep ones. Neighbors dot where N visited dot contains n dot as pair. So we only want to keep the ones that we have not visited. So we only want to keep the ones where we have not visited. And then this, we'll have this return a list. 2 lists. All right, so we get the neighbors, all of our, ooh, and we only want the ones that are, so we only want them to we've been visited, or in our height map that position is at most 1 greater than our current position. Man, should my positions have heights in them too? No, they can't, because I need to look it up on my map. I'm gonna look up on my map. I feel like I've approached this in a very poor way here. Yeah, I actually love, so Keith talking about using Unix style systems. I really love on Windows, I'm on Windows 10, but Windows 11 Travis is the Linux subsystems. Like, you can, if you really want to be on Linux, I can just be like, oh, start up a Linux terminal, and then it like mounts my device on there, and now I have an actual Linux, an Ubuntu machine in this case. So I love that. Yeah, so the only reason I use Mac is because all of my students have them. It's what their parents buy them. It's crazy. So 2 years ago, or 3 years ago, I started working at a school that was bring your own device, and all like 90% of the devices were Mac. So I decided I needed to learn how to use Mac so I could help my students. I've warmed up a little bit to Mac, but I am not a huge fan of Mac in general. All right. I need to, all right. I'm getting too distracted here. Okay, so I need to get the height of my current position. So int current height equals map map. That's a bad name. From dot row from dot column. So that's my current height. And then I only want to, all right, so, geez, public. My height map, I'm gonna do a better thing. Can move, I'm gonna write a method. Public bool is neighbor. All right, so we're gonna take in 2 positions, and it tells us whether or not those positions are connected. Position from position to neighbor from to. From and to. Yeah, I love the X connection on Windows machines these days. It's fantastic. It's really nice. I use Docker all the time. So I guess Docker's not technically a VM, but on Windows it's like running in a VM. But yeah, I use Docker all the time when I'm working. So return, all right, int from height is equal to map at from row to dot row, not column, and int to height is equal to map to dot row to dot column. And then we're going to return 2 height can be at most 1 greater than it. So 2 height plus, from height plus 1 is less than or equal to 2 height. Is that right? So if my current height plus 1 is less than or equal to my 2 height. Let's think about that. I'm going from height 1 to 2. 2 is less than or equal to. If I'm going from height 2 to 1, 2 plus 1. No, that's not right. Two height can be at most 1 greater. 2 height can be at most 1 greater. If 2 height is greater than from height plus 1, we return false. Return not this. Which means 2 height is less than or equal to. So if our 2 height is less than or equal to from height plus 1. So if our from height is 4 and our 2 height is 1. There we go. There we go. So that's if it is a neighbor. We also want a condition that 2, if 2 is not on our map. All right, we'll do one more. Public bool is on map. P return P dot row greater than or equal to 0, and P dot row is less than map dot get length 0, and C dot P dot column is greater than or equal to 0, and C dot column is less than map dot get length of 1. So we are only, oh geez, P dot column. All right, is, we'll call this is in bounds. All right, so with those, I can do a filter now where I say map dot is in bounds n, and map dot is neighbor. Well, I already got all the neighbors. It is inbound and it is there. Okay. All right. Mab retired. So instead of coding, Mab does coding puzzles. Oh, badminton, it's hard. Badminton is hard. I'm terrible at badminton. I had a is table tennis the same as ping pong? We always called it a ping pong table. So we had a ping pong table when I was growing up. I don't know how we got it. I think we found it in a dump or something. So in a because I know we didn't buy it. We couldn't afford to buy a ping pong table. Somehow we have one. Is table tennis the same as ping pong, or is those actually two different things? Q. All right, so now we're gonna say, well, our queue is not empty. we're gonna pop out the next thing. So this is gonna be the position we're visiting. Visiting equals toVisit.dq. This is going to be a tough puzzle for my students. I don't know if I can call my guide a beginner's guide on this one because it has this interesting algorithm that you have to be able to solve. Okay, so table tennis is the sport, whereas ping pong is not. Is the table size different or the paddle size difference? Is there? I guess I could Google it. I just thought you might be able to give me that information. Visiting, we are going to add this to our visited. So visited.add visiting.as visiting as pair. I'm just going to call this P. So we add it in there. Then we need to get our neighbors. Neighbors. Oh, and Keith, I'm sorry I named it Get Neighbors. Neighbors P, and then we have to keep track of our visited. And then we're going to add those. Well, first off, if we are at the end, if we're at the end, we're kind of done, right? If P dot as pair is equal to this name position's terrible. It should probably be something like waypoint, keeping track of a point, and then I need to type and then just use pairs for positions. So I'm gonna have to do some annoying refactors. Find neighbors, that's better. That's better. Keith, the master namer, find neighbors. Oh, lovely, lovely. Get neighbors is a foolish name. If this is the same as the end as a pair, we're done. We just return P. And that's going to be, we've reached the end, if that's the case. Otherwise, we visit this location and get the neighbors. We're going to add those to the queue. Trying to add all. Add range, I think is what it's called. What is the list dot? Oh, in queue. In queue, can I in queue a whole list? Oh. C# Q in Q range. Do I have to write this? Yeah. Neighbors.for each is what they say to do toVisit.enqueue. Gross. Gross. InQ should have. There should be an InQ all for Q. That's fascinating here. Well, I just don't. This looks kind of gross to me. Just like I hate this dot for each. It reminds me of JavaScript, which is gross. I don't want to write in JavaScript if I don't have to. So let me say it's better than writing an explicit for each loop. Is this it? Is this all breadth first search is? I check if I'm there. If not, I get my neighbors. I add them to the queue, and then I just keep going until I find it. I feel like there's more to this, and I've just been distracted here. Let's try a solver. Let's see if we get it. I've been distracted chatting with you guys all this morning, that I haven't really been paying attention to my code. I haven't been writing unit tests, so now I'm in trouble. Now I'm in trouble. And we'll say position and equals solver.solve. Let's print this guy out. Console.writeLine and I think it's gonna be gnarly because of where's the professionalism? This is the problem I have with working in an office. Oh no. Oh. Okay. It's trying to print these out recursively. I know, I need to overwrite toString on this. Public override toString. Position row. Oops. Is that how you do an explicit row? I guess I could be some row, column, and then we'll do our parents from column, from hang on. Oh, I wrote this as pair. Here we go. As pair from dot as pair. From question mark as pair. It'll display null otherwise. All right. Position 2-5 from 2-4. Row 0, 1, 2. 0, 1, 2, 3, 4, 5. Okay, it looks reasonable. So I guess we can create in our position, we'll do a backtrack. All right, so public list, and I should really be doing these IE enumerables to make them iterators, but I'm just bad at programming. Position path. All right, we'll get the path to it, and so we just need to say we'll make it stack. Will be fancy. Position back track. We'll push all these on and then we'll pop them off into a list. Is that what I'm gonna do? I'll just keep a list and then I'll reverse it. I want a linked list so I can just add them in reversed order, but I really don't want to deal with it. All right, so we'll say backtrack new. It's gonna start with this, and then we'll do position current equals. I really want to write it recursively, but I'm just gonna do it so that my students don't have to. Well, current dot from is not equal to null. We'll get the previous position, current equals current dot from, backtrack dot add current, and then we reverse it. Backtrack dot reverse, return backtrack, and does this reverse? Reverses the order of the elements in the list, and then let's dot path string dot join the path there. This is a function. Geez, we'll ignore that. I know it's there. Zero goes to 1, goes to 0. Oh, no. This is just... Alright, let's just get the length of this. Console.WriteLine end.path.count. I guess I don't really need to reverse it. What is it? Oh, it keeps telling me that that could be null. Okay. And the path to reach the goal is 31 steps. What have I done wrong here? What have I done wrong here? Oh, the distractions. The distractions. Oh. All right, let's do our path here. List position path equals end dot path for each position P in path. Console dot WriteLine P dot as pair. Well, console dot WriteLine at string join path dot select EP dot as pair. Okay. 0, 1 goes down. And it goes here. I must have it just ignores the heights. I must have my is neighbor. This has to be wrong. Yeah, my is neighbor has to be wrong. So let me stare at it really hard. Oh, duh. Still wrong. But I'm at least having the right height. My 2 height, it is a neighbor. Or I'm not filtering properly. Oh, I didn't actually call his neighbor from 2. I didn't actually use it, so it was just using all of them. All right, guys. I'm blaming you. Stop distracting me. Definitely your fault, not my fault. Okay, there we go. I think, console.writeLine path dot snap accelerator. No, I do this because it's fun. It's fun listening to you. It's so nice. I don't get to talk. I work with kids all day, right? So I rarely get a chance to interact a whole lot with people who are solving these types of puzzles from scratch, or just have some sort of, you know, programming, computer science, software engineering background. So it's really, really cool to do that. All right. Path dot count. All right, 31. Come on, baby, give me a 31. 32, off by 1. Minus 1. I don't think it. All right. The fewest steps required. So it's the steps required because it's not counting the end step there. All right, so it's off by 1. Let us try it on our input. Oh, I didn't need to. Oh no. Do I have an infinite loop? I have an infinite loop. Yeah, I agree. I agree. It'd be good to work with some of these. Maybe. Sometimes solving puzzles, yeah, I have an infinite loop somewhere. So I'm sad. I don't need to display this. I definitely have an infinite loop in my solver. Boy. I add it to my visited. I enqueue them. Oh boy. This is where having sort of a step function of like, here, I'm going to do one step would be useful. So I could debug that because something's going on. So I could set up situations and test it out. My guess would be that this hash set is not working well. So I could use the debugger to try and do this. I think I might have to. Oh, it's fine. The debugging in VS Code's great. So let me add in a breakpoint here. Oh, getting it started. How do I run, start debugging? Why is my debugger? Well, I've done something. Hang on, I got. How do I hide this thing? I don't know what I've done here. All right, I don't want that. I'm gonna remember that. I've only debugged, so I've never run the debugger from a program like this. I've always do it from a unit test. So let me set up a unit test real quick. I've never had to click. Well, I have done this. I don't know why that it can't detect. I don't know what's going on with that. It can't detect what I want to run as my program. Let me do it from a unit test. Keith, seems great. Seems great, yeah, I know. Let me set up a unit test here. I'll just have my unit test be this. And I think it's because I have it set up as a solution. If I was in just this project here, it doesn't know what program to debug, I think is what's happening. Yeah, so I just think it hasn't been configured just yet here. All right, so if I have a test, I can debug here, and then the debugger starts up for me because it sort of knows where to start. And the debugger doesn't know how to find this file. Because it's not in that project. Here, let's see if I move this in here. It's running it from this directory. All right, let's try again. No whammies. Come on. File not found. Oh, it's from like my input. Hang on, let me just do the following. Let's take my input. I didn't put that in the right spot anyway, but we're just gonna create. All right, I don't know why I'm doing this. I don't know why I have my window so tiny here. Let's go to my unit test. String input equals. Here we go. Here we go. Input dot split on new lines. This should do it. Yikes. Let's private static read only string. Yeah, I need to set something like that up. Okay. First try, right? Oh my goodness. What am I doing wrong? But was not handled. All right. All right. Bear with me here for a moment. Bear with me while I try not to lose my mind. Should I not be splitting? Nice index out of bounds. I know. All right. So I'm gonna show you the debugger here. Let's do it this way. I'm gonna add a debug. I'm gonna add a breakpoint here so we can see why my unit test. Why my unit test? Why is it not breaking? My breakpoints aren't working. What? Did I not add a breakpoint? Do I have to add it here? I swear I've done this. I was doing this yesterday. There we go. I just had my breakpoint in the wrong spot. Okay. String, we have all our rows. Is there an extraneous character? Did I split wrong? Step over. So the debugger in VS Code, I think it looks great, and there's some different settings you can say, like show me global things, not just local things. It works great when it works. I don't know why. is... What is the length? My guess is that one of these is not the right... When I split it, they didn't trim properly. Those individual lines aren't trimmed properly, is what's happening. Okay, so my unit test... I think these are not getting... Something's going on here where we don't have the correct thing. I'm just gonna do this file that read all lines. We'll get my example. I'm just gonna put this in the right spot. Well, it should be trimming. So I have it being trimmed. What I could, here, let me try this in my parser. Let me... Oh, you're probably right. There's probably some stupid thing like that. You're probably right that there's... Okay. Let's try it. Let's try that. And let us come back into our height map. We'll turn off this breakpoint. I don't know why I have a breakpoint here. Because I clicked there, I suppose, at some point. Let's try it again. No, same thing. Same thing. Fascinating. Yeah, that's what I was thinking. There's something wrong with how the line ends. In the... Let's use a smaller input for my brain to figure it out. Public, private, static, read only, example, string. I know. That would save me pain right now, wouldn't it? Trim. Can I just do a split? Would that solve my problems? Probably not. No. All right, all right. What do these look like? Right here. Well, first off, let's make sure that I have the same issue. That would definitely solve my problems. Okay, same issue. So something's going on here. I'm gonna add a breakpoint here, and then look, with these smaller strings, it should be easier to see. I know. Sometimes your brain's just like, I want this to... It needs to work the way I want it to work. Yeah, look at that. Oh. Yeah. Windows strikes again. Windows strikes again. So I think it actually has... Well, let's see what this looks like. Windows with its carriage returns. And now I have both. Yes, I need to do... You're right, I need to do a trim per line. All right, we'll split it this way, and then we will select. Let's go to s.trim. .to array. All right. No, not what I wanted. Stop. No, this is gonna tell. Now it's gonna spin. My test is gonna spin. Oh, good, good. I wasn't using the big input. I need to add a timeout here. Timeout equals 5 seconds. The capital T. There we go. Okay. Stop. Kill my breakpoint. Let us actually debug it. So there's one weird thing that here's something that sucks about unit tests. Here is if you don't have that timeout in, there's I can't get it to actually kill the test server if there's an infinite loop in a test somewhere. So let's make sure my visited rows the way I'm expecting it to. Okay. So I get my position. I add in 0, 0. I find my neighbors. And my neighbors are correct. In debug, it kills it. No. So I'm saying if I do like just a regular run test, it will... Actually, it's okay if I click this run test, it's fine. It's actually this extension. If I run them through this extension, it starts up a test server that tries to create it's interesting. It creates a process for every test or something. I don't know exactly what it does, but then you end up with test servers running and you have to hard kill them. You have to essentially kill -9 them, kill the process. Okay, we're debugging here. I was in solver. I'm about to enqueue my neighbors. All right. And then I should get... where's debugger? My count should be 2. And I add that in. All right, so my set grew fine. And then the neighbors on this one shouldn't include 0, 0. Yeah, it doesn't include 0, 0, which is what we want. All right, let's put our big input in and see if we can find where we start looping back and forth. Let's see if we can find where that loop is. All right, so let's do input. Hopefully it's not super far in. But we should be able to just start continuing. And I don't want to keep track. I need to add my breakpoint here. So that I have my position, so I can see 17. I want to see if my positions start going back and forth. 21. 21. 16. And I suppose it might have just been easier to print these out and then see, like, look at the pattern. That's probably what I should do first. Print it out so I get an idea of where I am when the loop starts happening. Console.writeLine P. And then run it. Get an idea of where that loop is. And I'm seeing position. Interesting. Oh boy. That doesn't seem helpful. Find neighbors P visited. I think I need to debug my find neighbors. Is this ever empty? There should be times when there are no neighbors to add. All right, Keith, have a wonderful sleep. Thanks for hanging out. Thanks for checking in. Take it easy, my friend. We'll see you next time. Oh, I thought this was not... I thought this would be pretty straightforward. Yeah, I think that's what I'm gonna do. I need to write some unit tests for find neighbor. Just to make sure that's where the bug isn't. My intuitions tell me that's the issue. And so we are going to do that. Let's rename our unit test file here to test solver test. Solver test. And let's build in a test here. Okay. Test find neighbor. Okay. So solver find neighbors from position are to position. So I need to sort of construct. I suppose I can use the example here, but I'm not sure that that is going to be super helpful. I think I need to come up with my own map here. So we'll start with a map that is A. We'll do this. Z, A, Z. We're gonna start from that middle position. Yeah, so this one, I have a lot of stuff going on today, so I don't know if I'm gonna actually be able to write this. Like, the concept of this solution isn't that bad because it's just a breadth first search. But now I have some bugs in it, and that's rough. All right, so we're gonna find neighbors from So position position to check is equal to new position row 1 column 1 null. So we're going to check various things that look like this. And I suppose this could just... All right, find neighbors to check, and then we'll have hash set int visited to check visited. This should be an empty set. Assert dot count. Can I do that? Assert dot equal 0 dot count. What does it tell me here? It says wants me to do this. List position results equals solver dot find neighbors to check visited. And I'm not sure what it's complaining about. Result dot count. Do not use assert dot equal for collection size. What should I use for collection size? Empty. Okay. I know, but then I have to like really reason about it. I'm just gonna go through and I think I'm gonna build this up for myself here. You're probably right that I should use this, but then I have to, it's hard for me to look at a letter and reason about, well, maybe not. Maybe I should just use the example input and look at each position and think it through. All right, Smab, you've got me convinced. There. Now I can just look at it. I wanted to have it sort of organized in a way I can see it. All right. All right, so yeah, it's somewhat easy to visualize. I just want to think through here. If I have if I am in this position and I haven't visited anywhere, I should be able to go to all of my neighbor positions. So I'm gonna make this a list of int select well the hash set. So my neighbors, my expected is equal to new, and my positions, if I'm in position 1 1, my expected neighbors are row 0 column 1, row 1 column 0, row 1 column 2, and row 2 column 1. And so now we'll assert equal expected result. Expected. And we'll slowly build this up looking for that. Oh, instead of building out these, that's a better idea. That's smart. That's smart. Do you know which one of these I should use to check that it has a size? So I wanted to do equal for that count. Oh, that's fine. It was yelling at me, telling me not to do that. I think it's because I had size 0. Okay. So now let's add into our visited. This is where functional would be nice too. I wouldn't have to manage state in my test. Visited.add 0, 1. I'm gonna slowly add in the neighbors here. We should only get 3 back. The other neighbor was 1, 0. We should only get 2 back. Ooh, I can even just do, I like this better. To check.north.as pair. To check.south.as pair. To check.east.as pair. And finally, to check west. This is where it wants me to check. Empty. And then this one, what is it? Want me to do on this one? Do not use assert equals for collection size. What should I use for collection size? I'm gonna keep doing it. Oh, equal. Bring my tester back up here. There, okay, so assert dot collection dot, and then is there more methods on there? So I did see that there was a collection. Do I have to tell int? I'm just not sure how to use it. That's all I'm saying, and I don't. Assert collection x unit. Let's learn. Collection, and then you have to do count. Something like this. So it accepts the collection you're doing and then some kind of function. X unit collection. Where's the documentation X unit? I don't want to read the documentation right now, but I guess I should. All right, we'll do assert dot collection null. And we'll go look at collection here. The type of object to be verified, an LM's inspector. Is that just what it wants for? So it's totally fine. Well, that's what I was. Yeah, it's totally fine. The warning is just particularly interesting to me because the warning's interesting to me because it says not to use equal for checking size. Do you get a warning in Visual Studio if you do the size like this? So I'm checking that the count is equal to 2. The warning message. What is the offered fix for equals with a non-1, non-2 against a collection size? Is there one that offered for that? Okay. Okay, so I guess the warning is just... Okay, the warning is just odd, we'll say. All right, so we've done this one. Let's try from... I want to find a position where I cannot go certain directions. Let's try this position here. Or even right here. 0, 1, 2. All right, row 0, column 2. Yeah. Ooh, one with a jump of 2. I like that even better. A to C. We'll try this one here. Row 2, column 0. Row 2, column 0. Row 2, column 0. Yeah. And then we'll reset our visited. You're right. You're good. This is fantastic. Thank you. Thank you for essentially pair programming with me here. My students either love pair programming or hate pair programming. Let's try this. To check. Visited results. Okay, so let's keep a copy of this nearby. Or probably break this into smaller tests is what I should do. Test, find neighbor, all directions. If I am in fact testing individual functionalities, that would be the way to do it. So test neighbor with 2 height. That's a terrible name, but that's sort of what I'm thinking about. It's a neighbor that has 2 height, so it's not great letter N. So I could have this go off by 1. That would be interesting. It can be pair programming can be horrible if you're paired with someone that you have trouble working with. I remember, so I would often pair program with data scientists at my my pre-teaching career. I had to pair with data scientists who were doing machine learning stuff for us, and that was just a nightmare because they don't know. Not all of them. I shouldn't generalize. They don't know. Some of them don't understand how to architect and test, and you get these giant methods. That were just awful to try and solve. Okay, so we are trying this position. I kind of want to find one where we're 2 up but in the middle. Do we have a case like that? A, B, C, D. This is why I kind of wanted to construct them by hand to test that out rather than using the example, but I suppose the example's okay too. We're gonna try this one. All right, so row 0. That's, why would I do that? That's crazy talk. I'm actually gonna it's hard to know exactly what I've changed if I'm using these examples. All right, here. I'm just gonna use this example. I'm gonna go here. 0, I'm sorry, row 2, 0, 1, 2, 0, 0, 1, 2, 0. All right, to check, find our neighbors. We should have just 2 up in north and south. So we should have just 2 north and south. Yeah. And then if we add to our visited, position 1, 0, and we run it again, we should have results of 1. It really wants me to do single here. And then if we add in to the south, we should be empty. Okay, so that works. Okay. Test neighbor jump down. Make sure we can jump down a long way. Let's try Z here. Let's see here. Yeah. 0, 1, 2. 0, 1, 2, 3, 4. 2, 4. Visited. Null. Initially, we should be able to go in all directions. If we add in 5, can go 3 directions. If we try to go south 3, 5, well, we should be able to go in all directions, so. Um, 1, 5. And then to the left. Okay. So I think I'm kind of feeling my find neighbor is working. I have a little bit more confidence that find neighbor is working here. And I actually think that I must... There must be a bug in my solve. So I kind of think I need to break this down into this inside part. Just this inside part. So that I can check that it is mechanically working, just this internal piece. So I think I need to write a public void step and step yeah, so I'm like 90. No, the error I'm getting is I have an infinite loop. So my program loops it. I'm assuming it's an infinite loop. I didn't let it run very long, but this shouldn't take that long to finish. So if I run it, well, let me leave it running for a moment. Yeah, so that's what I was thinking. I was like, breadth first search should be fast. It should be really, really fast. So I sort of have an infinite loop somewhere. Yeah, the first time I ran it, it just didn't finish. Yeah, so it shouldn't take this long. So I'm assuming I have an infinite loop. If I had done it recursively, although I think recursively might be hard to do here. Depth first search is easy recursively. Because if I'd done it recursively, I would have gotten a stack blow up, and I could debug it then more easily. So I think I need to write unit tests just for this internal part to make sure that at each step the program's manipulating the state properly. So I think I'm going to write a step here so that I can just do one step. So I can debug it that way. Step is going to need a queue. And this is going to return a position question mark. Visited is my hash set. I don't need these labels. Although I guess it doesn't hurt. And then I say if step to visited not equal, what I need to do, position and equal step to visited. If end is not equal to null, return end. Yeah, you did mention you hated it. I haven't. That's not true. I have. We usually do a maze solver in my class once a year, so this shouldn't be that hard for me to solve. But for some reason, I just have a little bug in here. somewhere. Let's make sure this still works for the example. Although I don't know that that's super helpful. I'm just trying to implement a breadth first search, and I am, for some reason, having a infinite loop. I'm not tracking the state properly somewhere. So that's why I've broken out this step here that will process a single check, and I can sort of ask. So I think my find neighbors is working. But now I have a single step where I can sort of go through and write a unit test saying, okay, given these conditions, can I, where, you know, how does this modify the state of the program? And so that's where I'm at. I need to write a test here to try and solve this bug. Alternatively, I think I could look at breadth first search implementation and just make sure I'm not missing something obvious. But I think this is it. You get your position, you check if it's the end. If it's the end, I return that. We mark it as visited. We find our neighbors. We add our neighbors to the queue, and that's one step. So let me just go make sure breadth first search that is, I'm not missing anything crazy. We add our root. Well, it has elements. We dequeue it. If it's the goal, we end. This is hilarious because I've written exactly this so far. And I say, get all my neighbors. If we haven't explored it, its parent becomes us, and then we enqueue it. Okay, so this is right. So my neighbors must be, I must have, there must be a bug in my find neighbors. It should be, man, this is so annoying. North, south, east, west. I am in bounds. My bounds check looks fine. Well, let me test my edges, my to height is less than or equal to my from height. Yeah, so something's wrong with my find neighbor, I think. Oh, my mouse is acting up. Okay, let's keep looking here. I'm a little embarrassed, to be completely honest. I was thinking I was gonna get this part one pretty quick. What's going on? My mouse is giving me trouble. Visited. To visit. Find neighbors P. Visited. North, south, east, west. I don't need a current height here. Yeah, I think that's the next thing. I'm just wondering if I can We keep it if it is in bounds. Is a neighbor. Does pair. Alright, let's try each of our edges. Let's try it here. Yeah, my is in bounds code fills. Pretty standard. My row greater than or equal to 0, less than or equal to the size of my map in the row size, my column. Like that. That feels hard to mess up. But let's check. I know. When you get into these situations where it's like, well, it looks right. And then you have some weird thing. So we're going to test corners. We're going to test that the corners give us back what we want. So position 0, 0 should give us 2. I know. So this is where this is going to be helpful, I think. 0, 1, 2, 3, 4 high. We should get 2. And then the width of this 0, 1, 2, 3, 4, 5, 6, 7. I have like this hope in my heart that oh here we go. It's gonna be this. We're gonna find it. This test one isn't doing anything. We'll delete this. Let's run these. You know what? I wasn't actually running my jump down. I was running the wrong test. So here's my bug. I wasn't running this test, Smab. My jump down tests. Oh, okay. I was just rerunning the last test. That would do it. Okay, we're about to find it. Yeah, exactly. Well, I had so much confidence that you were correct. I was like, yeah, it is definitely in my find neighbors. It has to be wrong. So when I add, so I'm at Z. If I add in 3, 5, that'd be 1 row down. The count is 2. So something height map. All right, so find neighbor. And let's make sure my test here. Oh, that's so sweet. So I actually am cross streaming on YouTube. So I think it's Jacob or Jacob. I'm not sure. Thank you for the compliment. I appreciate it. I'm glad these are helping you. I don't normally look at. You're the first person to really post anything interesting in my chat there. So thank you for. Thanks for watching. I'm glad they're helpful. It gives me a lot of, I don't want to say joy is not the right word, but it keeps me motivated, fills me with satisfaction to know I'm helping other people. I love teaching. That's what it comes down to. I could make and have made so much more money doing software engineering for companies than as a teacher, but I just love teaching. I've always wanted to be a teacher. So I appreciate that. I'm happy it's helping. And if I'm sorry I'm not putting up part 2s, I've had a lot of complaints about that. So I'm sorry if that's disappointing. I actually went to school to be a music teacher. I have a music education degree. But I just loved programming too much, and it turns out the fine arts unfortunately get very little love in public education, and I cannot it hurts your soul too much. It's too stressful. Okay, so find neighbors is broken. I add 3, 5. Let's debug it. Let's debug find neighbors. Find neighbors. Yeah, and then I do have a degree in computer science, so I got I went to University of New Mexico. That's where I did my bachelor's, and I went to grad school, UMass Amherst. I was accepted into a PhD program doing computer science education research, and that was again too stressful for me, and there's a lot of things going on. I didn't finish my PhD program, but I did experience grad school. I got a lot out of it. Okay, so let's step over. What is visited here? Visited. Why is visited count 0? Oh. Because I put it in there. Hang on. Stop. This is not where I want my breakpoint. I want my breakpoint in my tests. Here. Debug tests. Yeah, I started out as a music major, computer science minor, and then I ended up really enjoying, and I had a ton of programming experience before that, but not any sort of formal education. So the college stuff with the formal education was great. I learned so much. I remember thinking before that my problem solving skills had developed so much by that point that I could hack my way through stuff, but then learning about time complexity, learning how to understand time complexity was such a huge thing for me, and I loved my discrete math class. A lot of people hate discrete math. I thought it was great. So what does results contain? Results contains 3 things. 1, 4. So I'm at 2, 4. It contains 1, 4, 3, 4. Oh, you know what? I wrote my test incorrectly. Because I was hang on. Oh, if you write a bad test, of course it's gonna fail. So 2, 4. If I add in 2, 5. Alright. If I add in 2. Here's what I'm gonna do. 2check.north. I'm about to be really sad, aren't I? If this... Oh. To check dot east. To check dot west. I'm about to be really sad. Please fail. I've never wanted a test to fail more. No. Oh. Oh, man. test corners. Yeah. Part of me is going, okay, let's start over. Let's build this from scratch without the stream chat, so that way I can actually focus. No, this is great. I actually love this, so I can point my student once I finish this. I'll be able to point my students to say, look, this can happen to anyone. You think you have a plan, and then something happens, and the question is, how do you persevere? What do you do to figure out where things were not working? All right. It has to be in my neighbor. Let's test isNeighbor. All right, we're gonna do an isNeighbor test. Height map test. I don't know why I decided I needed to copy that. I thought there was something I had to extend to make that happen. Oh, we're working through it. We're working through it. Okay. We are going to int array. Can I declare this in this way? Map. You can. Good. That's the part that I am it did work. That's the part where I'm mostly confused, is the sample data. The sample data goes fine. So I'm breaking it down. I'm breaking it down piece by piece to find where I've gone wrong. Height map equals. That is interesting. Is my parser... I haven't... Well, I did verify... Okay, alright, well let's verify that. That's a great test. That's a great test. That's a great test. Okay. Because I do parse it into an int array, a multi-dimensional int array. That's a good test. Let's take this and verify that what it's supposed to be here. All right, so this is going to be a little painful to go through, but we should have 0. Oh, this is... I'm gonna have to get good at alphabeting. And just to help me out, Q S T U V W X Y X Y Z. So I should have, this is just so I don't have to go back. Give my brain an easy lookup table. So it should be getting me this. All right, should I set up 0, 0, 1, Q 16, P 15, O 14, N 13, M 12, A B C R should be 17, Y should be 24, X is 23, 23, L 11, 0, 3, 2, 2. This, it'd be great if this was my issue. 18. We checked your sample parsing earlier on that. Matched perfectly. I don't know if it matched perfectly. I eyeballed it, checking if it was. If it matched perfectly. So I printed it out and it looked correct at a glance. Well, but my logic makes sense. All right, well, let's... All right. Let's output this to a file so we can look at it. We're not gonna solve. You know, it would be crazy if my solver was working, but my printing the path. Oh my goodness! Don't tell me that's the case. It's not. Okay. To output. Let's take a look at output. That looks cool. All right. And get my input next to it. I'm not even sure how to... At a glance, it looks fine. So like I'm seeing this sort of heat map here. That's cool. I don't know, that looks right. That's so cool to look at, man, because the numbers, because it's spaced out so that the bigger numbers take up more width, you can see them. That's kind of cute. The way that kind of worked out for us. The number of rows and columns, let's check it. Let's check it. We're continuing to debug here. Thank you for pairing me. I know it's late for you. Console.writeLine map.get length 0. (41, 143). Do you know if that's correct? Oh, in the afternoon? Jeez, I was thinking when you were telling me that last time, I was thinking it was AM. Oh, for some reason I thought you were in a time zone where it was nighttime, like super late. Okay, I am less worried about you now. I'd been worried that you weren't getting the sleep you needed. Keith is late. Gotcha. Let's do console.writeLine rows of 0 dot length. Then they should match. Yeah. So this is where a visualizer would be pretty nice. to see where I am stepping, what my neighbors are, that sort of thing. Oh. What a disappointment. What a disappointment I am. Okay, so we are going to test. We're gonna test our is neighbor with a bunch of stuff here. Test is neighbor. So I was gonna construct an actual map from scratch here, rather than trying to decipher the inputs there. I should be able to construct tests here that will check. So we have conditions where you're on an edge. All right, on an edge. You should have neighbors that are next to you. You should be able to go down. All right, so we got our corners. We can go down. You should be able to go down anything that's less than you. You should be able to go into a spot that is equal to you. These zeros should not be able to go. That should not have neighbor here. All right, so let's slowly test these out. Test neighbor same height. So position from 0, 0. No. Position 2 equals new position 0, 1. No. Hang on. Is neighbor really only cares about the height? Which is fine. Only cares about the height. So 1, 1. To make a map, height map, from 2. Map. This is HMap. Ugh. All right, I almost am gonna need a break here. I'm almost out of time too. I have to stop. Not out of time, but considering how much time I've put in, I've got 40 minutes till I need to stop, and I'm just so frustrated right now that my breadth first search is not working. And I can't find my bug. HMap dot is neighbor. Maybe I need to write a different method here. So my HMap I can get. Maybe that's the strategy I'll take real quick. And my hype map public list row, column, get neighbors. Let's call it find neighbors. Int position p. Maybe this is what I want to do. Yeah, okay, that gives me confidence that it's just another Breadfurt search, but my guess is like something like from the top down, and you're not, and the end position is somewhere that's not your original start position. That was my initial thought. My fear was that it's going to have me doing Dijkstra's algorithm, so maybe you have some rock climbing gear or something. But we'll see. We'll see. We're going to get all of the positions that are near it. And we're going to change is neighbor here. We're going to break it down into even simpler steps here. List, int row, int column. Neighbors is equal to new p dot north, p dot south. Ugh. As pair. Am I just doing the same dumb thing again here? Public bool. I'm like I can feel a minor desperation. Public static bool height. Check heights. Check heights. Int from height. Int to height. And this will just help me reason about that real quick. Cast height check. Assert true height map dot check heights. I should be able to go from 0 to 1. I should not be able to go from 0 to 2. I should be able to go from 2 to 0. And I should be able to go from 0 to 0. Okay. That, am I missing anything crazy here? I can't jump up. Can jump down. Can step up. Can step 2. Okay. Then in my column, let us go to, let's get rid of is neighbor, because that is not a useful thing. Instead, in my position, I'm going to have public position array of sorts. There, okay. Neighbors. And this is just going to be was that? New position array of north, south, east, east, west. So we're gonna get that back. And let's test that we in fact have the neighbors we're expecting. All right, so we're debugging it. Public position test. We're gonna test it upward the way we should. All right. Slowly build it up. Here. Test neighbors. Position E equals new position 0, 0, null. And then we will say that position array expected. Let's start in the middle. Equals. Okay, is this a fancy thing that I didn't know I could do? Yeah, I'm gonna be so. I already know I'm gonna be upset when I find it. Because it's gonna be something so dumb. This should be a set because the order doesn't matter. Hash assessed. All right. I'm gonna be real upset when I find it. You're so right, Smab. When I find it, I'm gonna be really. I'm already a little bit. I honestly feel like if I looked at expected p.neighbors. Let's rebuild my test here. I had one this week where my solution was correct, but part 1 was corrupting my starting position. Yeah, I think I remember that. My tests are now I have compilation errors because I've modified, but it's in my solver. Yeah, I've modified this. So we are now gonna start with a hash set position neighbors equals from dot neighbors, and we don't even need that. We can just say from dot neighbors where n is inbound, and this is going to be height map dot check height on our from dot. Yeah, we need to be able to get the height of a thing. So now this is just wrong at this point. Because my height map, so what I'm doing here is my height map's eventually going to give us our neighbors back. So let's go to my height map. That was yesterday, my brain is fried. So now this one, public static public hash set position find neighbors from a position P is going to be P dot neighbors. Dot where P goes to check height of map at P dot row P dot column map at I feel like I've written this in such a poor way. This is my neighbor. N dot row. N dot column. But that's not quite right either, because I need to filter out the ones that are not in bounds first. So neighbors dot where is in bounds. We'll do intermediate steps here. Maybe. And then we'll do another where. We won't combine these wheres into one, and I was trying to be maybe more efficient or something stupid. So we only keep the ones in bounds, and then we only keep the ones where our from height to height. From height to height. And then to hash set. All right. So now my now interesting. The assert.collection expects a list of element inspectors, one for every item in the list. The first inspector is used to check the first item. That's kind of cool. That's actually kind of cool. Okay. I think that's cool. I could have used that on some previous test I was doing. All right, solver. So my solver now should do my map dot find neighbors from dot where we haven't visited it. Make sure I haven't broken that. Still have an infinite loop. Man. Man, this is so annoying. My test for my position is good. My You're just trying to clean it up. Sometime this year, yeah. We'll see. Alright, I guess I should... I'm convinced that I can't possibly be wrong here, but let's try to test for my height map. Past, find, neighbor. To be so crazy, map or height. And then we'll construct our height map from this. Height, new position, 0, 0, new position. And I don't care. About that. All right, so 0, 0, 0, 0, 0, 0, 0, 0. Corners. Map.find neighbors. And really, I guess find neighbors doesn't actually care about a position. So this is, I'm gonna make this take an int row, int column. I'm gonna do it like that. Do I have to give it a name? P. All right. I guess the reason I did it was because I could use the neighbors. Oh, no, corners. Position, top left. New position, 0, 0, null. Position, top right. New position, 0, 2. Bottom left is 2, 0. Bottom right is 2, 2. And our expected is gonna be new position, 1 down, top left, new position, 1 right, top left. Third equal expected, top left, or map.find neighbors top left. Our expected from top right, we need to go down. Oh, top right is actually row 0 to column 2, yeah. To the left 1. Top right. Top right. And then down 1. Let's keep going here. All these should be bottom left. And if we go up one, go to the right one. Oh, how annoying. That's rough. So you had key values mixed up? Is that what you're saying? These should all be bottom right. And if we go from 2, 2, go left one. And up one. Let us refresh here. Oh man, that's an annoying. That's a really annoying one. All right, so the corners. Hang on. Test neighbors. Test height map. Oh, this is in the wrong namespace. There we go. All right, so the corners work. Test local minimum. What am I doing here? Why am I in the wrong file? Close all. All right. We're going to tests. Find neighbor. Local minimum. We are surrounded. We should have no neighbors. Honestly, the height map having the start and end is really silly. The start and end should be part of my solver. My height map just cares about the heights. So I have a bad design there. All right, I'm coming up on having to stop here, which makes me really sad. I really wanted to have I think I'm probably gonna scrap this, start from scratch. But that because I think it shouldn't be this hard to find my bug. We'll assert empty on map.find neighbors new position 1 1 null. Okay. Let's keep going here. Feeling slightly discouraged. Find neighbors, local maximum. And our friends here should be a hash set of positions. All right. Position start equals the middle. Start. And expected is going to be a new hash set with start.north, start.south, start.east, start.west. Failed. Oh. Okay. Oh, never mind. I've never wanted to fail more. Yeah. I've never wanted a test to fail more. I know. I know. I've never wanted to fail more. Tests. Same height. Alright. Test. Alright. Whew. Man, this is getting desperate. Test north. Alright, so this one is I'm gonna do north blocked. So the crazy thing is this is sort of the test I have so far should I really shouldn't be having to test much more than what I have here. North blocked. East blocked. Because if this is working for each of my potential directions, then it should work for all of them. North, east, and last one will be south. So let's put west back in. So I'm really feeling confident that this version of Find Neighbors is working. My Find Neighbors seems to be working here without any issue. So I guess my intuition of testing this step was right. Hash set. Let's make this a hash set. Just to make sure I'm not adding the same thing twice for each position P in to visit.enqueue P or N. If visited.contains N, continue. as pair. Ah, this is so wild to me. Okay. All right, I'm gonna stop here. I need to take. I've been going for a little over 3 hours here. I need to take at least a 5-minute break. Get myself another tea. Come back to it. Thank you for watching me flail here. I'm gonna keep working on it, see if I can find it. But my next thing is I gotta debug this step. Thank you. I'm gonna try debugging this step next, and then I'm going to scrap it. But I have to start teaching soon, so I do have to pause here. So I'm hoping I can finish this up. I don't know that there's a beginner-friendly guide to this one, right? So, in the sense that, yeah, I don't know that there's a beginner-friendly guide to this one. So I might create a guide just called a guide to day 12. Mine I felt was quite simple, but so when I say beginner, I'm thinking that someone who has completed the very first introduction to programming course. So they've completed a semester of programming. Up until here, I think all of the puzzles were really solvable by anyone with a single semester. The one puzzle that wasn't was part 2 yesterday. That one required some, I wouldn't call it advanced math, but a little bit of intuition about how modulus and prime numbers work. And then the pathfinding here, there is like an algorithm that is not necessarily easy to discover on your own. So there's a trick to pathfinding, right? So there's a trick of being like, oh, well, I know breadth first search or depth first search. So like maze solving is not really a straightforward approach. There's finding the shortest possible path. If you wanted to come up with that on your own, having just basic computation and thinking skills, it's not straightforward to do that. Anyway, I'm gonna hop off here, see if I can find my infinite loop, and pray. All right, Smab, thank you so much for hanging out. I see a couple other lurkers in the list of people who happen to be watching. So I'm gonna be trying to stream almost every day this week, and then I'm gonna be going on a holiday. But if anyone who would like to be notified when I'm streaming, feel free to click that follow button. But I stream every morning, Arizona time. All right, have a beautiful day. Good luck with all your refactoring. Smab, try and get some sleep, and I'll see you around. You're welcome back anytime.